Hello and welcome to another Thursday night Q&A. I'm happy to say I'm joined this evening by my colleague George Newham from our assessment team. Good evening, George.
Good evening, Sam. Good evening, everybody.
How's your day been so far then, George?
It's been good today, Sam. Yeah, I went in, I cover sort of central North Essex, shall we say. Went to a sort of recycling centre today, where they sort of recycle but sort of skips full from construction and stuff like that. Yeah, so it's been interesting. It's nice to see something sort of industrial as well.
Yeah, no, I guess you must sort of get to see a bit of a range of work, and yeah, because I think sometimes we fall into the old trap of everything's people's houses and sockets and lights, but it's a much wider industry than that.
Yeah, and it's nice when something sort of interesting comes up as well, and yeah, you definitely see a range for sure.
Okay.
So yeah, it's good.
Brilliant. So we'll start off with our question of the week, which we posted out across social media channels earlier this week. We'll go through the answers to that question. Then while you're putting your questions in the chat, we'll go through some of the previous questions from sessions that we didn't get around to asking or answering. So please do post your questions in the chat. Remember that there's no such thing as a stupid question, only stupid answers. And the whole idea of this evening is that we'll improve our collective knowledge and understanding of all things associated with BS 7671 and the world of electrical installation. So yeah, please do put your questions into the chat. That will be great. So without any further ado, the question of the week that we posted out earlier this week, as per usual, was a multiple choice question, and it was really prompted by something that happened last week where we got asked. So the question was, for compliance with BS 7671, what methods can be used to determine the prospective fault current at every relevant point in the installation? And the options were: A, can you do it by calculation? B, can you do it by measurement? C, can you do it by inquiry? Or D, can you do it by any of the above? And when I had a sneak look earlier this afternoon on LinkedIn to see what the current thoughts were, yeah, we were showing that 60% of the audience were saying any of the above, and 26% measurement, and then 12 for calculation, and 1% by inquiry only. So what's our thoughts there? What's the answer, George?
So the correct answer, so well done for everyone that put D.
Yep.
Any of the above. That would be the correct answer. Well done for everybody for having a go, to be fair anyway, because sometimes with winning it is because it is all free. Sometimes you think, I know that one, and you go for that one, don't you? But the answer is D. Yes, any of the above. It actually says that in regulation 434.1. It actually tells you that determination of prospective fault current can be by either of them methods, or shall be by either of them methods. So calculation, measurement, or inquiry.
Yeah, and the question that we had from an engineer last week was about well, why? And one of the reasons is if you've got an install, if you've got actually a live operational install, you might be able to do measurement, but when you're doing your design, you need to consider fault currents in order to get correct rating and sizes. So you have to do it in both instances, and so that's where calculation method and perhaps if you're looking at the origin, then inquiry to the DNO. Sometimes also inquiry when you're making an addition and alteration, you can go back to the original designer and ask about calculation. So that's why those all three methods, because yeah, the engineer we were talking to said, well, you'd always measure it, wouldn't you? And of course, when you're at design stage, you've got nothing to measure, so it would be calculation. So yeah, good. Okay.
That's good bits for that, yeah.
All right, so please do put your questions into the chat. It'd be much appreciated, and we'll try and answer them. Remembering no such thing as a stupid question. While you're doing that, we'll have a look at some previous questions. So the first one that we've got up is, do single insulated but non-sheathed bonding conductors need to be installed in conduit or trunking? And it's a common question, because especially when people start to understand that there is a regulatory requirement for single insulated conductors to be contained within trunking or conduit. But the answer to this is that for bonding conductors, the answer is no. Single insulated protective conductors, which includes bonding conductors, are exempt from having to be installed in conduit or trunking, providing they're adequately sized. So regulation 521.10.1 tells us that non-sheathed cables for fixed wiring shall be enclosed in conduit, ducting or trunking. But then it's got the second sentence. This requirement does not apply to a protective conductor complying with section 543. 543 is all about sizing the relevant protective conductor. So for example, in a TNCS system where we've got a minimum of 10 mil for our protective bonding conductors, for earthing arrangements that might be a minimum of 6 mil, and if buried without mechanical protection, that they need to be 16 mil. Then they do not need to be installed within containment. So there's an exemption for protective and bonding conductors, which means they don't need to be treated like our other conductors, for example, our live, our line and neutral conductors. Anything you'd add to that, George?
Not really, no. I think that's good that the regulation specifically sort of omits them as well, or clarifies it's not applying to them. Just generally, they're suitable for their external influences. I suppose if they were in a harsh environment where they're heavy impact, then general requirements might apply, but nothing specific in the way that it would be to obviously live conductors being enclosed.
Yeah. That's a good point, in that, yeah, we still, even though they don't need to be in containment, they still need to be suitable for the environment that they're installed in. Now that's a really cracking point. Okay, so please do populate questions in the chat. If you've got a question that's been rattling around that you've always wanted an answer for, or you'd like an answer explained, please do put it in and we'll try and help. A second one that we've got this evening is one that's becoming a bit more common. So with consumer units getting larger, where there's not enough space to mount it horizontally, so I guess we're looking at perhaps a double stacked, a dual DIN rail consumer unit. So where there's not enough space to mount it horizontally, is it okay to mount the consumer unit vertically? So effectively turn it on its side. But what's our thoughts there, George?
Yes. So theoretically, yes. Well, yes. But providing that obviously the manufacturer is in agreement, just to confirm that it's suitable, that either documentation states that be suitable for that orientation, just that the consumer unit will still comply with the relevant BSEN 60439-3, just to show that it's okay. Because when we think about three-phase distribution boards, for example. If you think of the orientation of them protective devices, MCBs, RCBOs, when you think of the standard domestic consumer unit, put it on your side. Obviously, the axial orientation is would then be the same, but it's just confirming for that particular assembly.
Yeah.
Another point would be the labelling. Any labelling, identification of circuits, etc., is still legible, so the correct way up, like you would do in a three-phase board. That would then be at an angle to the protective device, wouldn't it? So
it's probably fair to say as well that a lot of the devices are common, and we already mount them vertically in a three-phase board. So it's not as strange a method as it seems at first when you think about the fact that normally the protective devices are mounted on vertical DIN rails in a three-phase board and horizontal DIN rails in a distribution board. So it's not as unusual as it seems to put it on its side, but as you rightly said, got to get manufacturer's confirmation, because it's about heat and compatibility, because obviously depending upon the orientation, we know that heat rises. If we stack them vertically, then obviously the heat's going to go through all of them. Okay, another one about consumer units. After changing a consumer unit when no final circuit cables were replaced, in the scheduled inspection section of the EIC, what should be recorded for cables installed in walls, partitions, being installed in prescribed zones when the cable routes are unknown? So this is an interesting one, and it opens up something that's not often considered. So the simple answer to this one is that not applicable, and this is all about making sure that we really use the box on our electrical installation certificate where it says details of the electrical work covered by this installation certificate. We really state exactly what we're certificating with the EIC. So in this instance, it is just the board change and a reconnection of existing final circuits, which means you're not taking responsibility for the install of those circuits, and therefore it's perfectly acceptable to say that it's not applicable what the installation method is. So that's, I think sometimes people feel that when they do a board change, they've got to take responsibility for the whole installation, and that's not the purpose. And the installation certificate clearly lets you say, right, what work is covered by this certificate, and you've also got another option on that certificate where it says comments on existing installation, where you could, if you noted something that wasn't a safety issue and didn't prevent you from completing your work, then you could still record it, and by that way you're making it very clear that was there already and it wasn't something which you introduced to the installation. Would you add anything to that, George?
No, just that does, like what you were saying, that comes up in the field, here time and time again. So I don't want to change this board, I want to install a separate board because I don't want to take responsibility for this, but obviously it's not. It's so clear to just have that extent of works, details of electrical work clear, and just reiterates that the certificate is not just for the client, it's also for the contractor's records, and important, it sort of protects everybody.
Yeah.
That clarity.
Yeah, and it does. It lets you define what you're taking responsibility for, and it lets you record what was there already. So yeah, it's a fair approach in that way. We'll take one more and then we'll look, because we've got some questions in the chat now, so we can have a look at those. But we'll take one more of these. So again, a common question we get asked. So do the requirements of section 721 for electrical installations in caravans and motor caravans apply to installations within static caravans in residential parks? So quite often, you know, we know that we've got a special location section covering the electrical installation in caravans, but does that apply to the static caravans in residential parks, George?
No, would be the short answer. And it tells you that in the scope. Similar to anything in any special installation in 700, any of them locations, the scope is always a key bit, and it actually says in there they do not apply to the electrical installations of mobile homes, residential park homes, or transportable units. And it also states, but obviously mobile homes and residential park homes, the general requirements apply of BS 7671.
Yeah.
Reason being just because the risks aren't the same with these sort of static, fixed sort of park homes. They're not being moved about as much. Well, they're not going to be moved about, basically, are they? They're not being plugged in, unplugged. So there's just less risk of that. So just general conditions, that is wouldn't be the same as a caravan.
Yeah.
No.
Yeah. There's no movement, there's no vibration. Like you say, it's a static home will tend to have a fixed supply. Very different type of installation, and not that indifferent from a typical domestic. Treated as such and not considered a special location. But yeah, it's a good one in that it does clarify it in black and white in the scope. Okay.
See a few park homes where I am on the coast as well.
Yeah, I was in the February half term. I was up in Norfolk, and never seen so many, and some of them huge, absolutely huge. So more and more. I think it's one of those ones you don't realise how many are until you get into it. Okay, let's take a look at some of the questions that have come in the chat, and we'll try to see if we can resolve those. So first one is from an engineer that says, if you've got an SWA gland and it's glanded into a trunking system with an additional CPC in parallel with the SWA, but you bolt banjo to trunking, but you need an earth fly lead from the bolt or not. So I think the way I'm reading it is that you've obviously got SWA glanded into the trunking with an additional CPC in parallel. So whether that's external or whether they're using one of the cores, but you bolt the banjo to the trunking, but you need an earth fly lead from the bolt or not. My thoughts on that is, if you've got if you're using a proprietary gland for the SWA, then it's that will provide you with a direct connection to the armouring, and then if you've used it and glanded it properly into the trunking, you should have connection. But do you need an earth fly lead from the bolt or not? So I'm wondering if the engineer's asking, does the additional CPC need to be connected to the I'm not difficult. I'll read it once more. If you've got a SWA gland into trunking system with an additional CPC in parallel with the SWA, but you bolt banjo to the trunking, but you need an earth fly lead from the bolt or not.
I mean, is he saying, or she, is the person saying, as long as the trunking's obviously suitably earthed, so that then earths the SWA sheath?
I'm thinking, when I read it the second time, I'm thinking maybe it's, for example, it might be 2-core SWA, and so they've run a separate CPC, or it might be 4-core SWA for 3-phase, and they've run a separate CPC. Do you need an earth fly lead from the bolt or not? So you're going to it'd be interesting. I'm not sure how you'd bring that additional CPC in. So yeah, not really sure. Maybe a difficult one to unless we could see it, or a bit of a. The same engineer has come back and said the trunking is earthed. So yeah, there'd be no real need to have a banjo, providing that you've got a proprietary gland, which then makes sure that the casing of the gland is electrically connected to the
to earth,
to
basically.
yeah. And again, the engineer has said, it's 3-phase 4-core, so that's why they've run a separate CPC, because they've used all 4 cores for the 3 phases in neutral.
Yeah, I mean, if the truck, obviously, the key is the trunking's being earthed, which they've come back and said it is.
Yeah.
And suitably sized and everything like that, just to maintain that earth to the SWA sheath, maybe would be the only thing. Sometimes, the only thing is sometimes with, say, gland plates, and say the screws could become loose, and you might be reliant on. But if you've got a say solid trunking that's connected to earth correctly, then that would earth the sheath. That would be my thought.
Yeah.
Some people like to take a fly lead as well, perhaps.
Yeah, there's no harm in doing it, and it's a little bit of sort of belt and braces. But in terms of if we were asked the question, would it be a regular requirement to have a fly lead? No, providing that it was mechanically sound, which it should be, because you're using good workmanship and proper materials. But yeah, you do need to earth the SWA. You need to earth the armouring of the SWA, because that's considered an exposed conductive part, even though it's within the cable sheath. But obviously, when you terminate it or gland it into the trunking, then it can become exposed. So yeah, it would need to be earthed, but you wouldn't necessarily need to use a fly lead. Another question: now that BS 7671 has removed the time current curve graph for the old style 1361 cutout fuses, is there an easy reference or way to get the operating time T when carrying out an adiabatic equation? Well, couple of things. First of all, you can always use manufacturer's data if you've got it. So if you've got the fuse manufacturer, you can use the manufacturer's data. You don't have to rely on the time curve characteristics in 7671, because they're only the most common ones, and not all. The other thing is, with 1361, if I remember rightly, and I'm just going to check this while we're talking, yes, so if you go to page 386 of 7671, which is part of Appendix 1, and Appendix 1 covers all of the British standards that are referenced within 7671, and on page 386, if you look at BS 1361, it says it's been replaced by BS 88-3, so you can use the BS 88-3 time curve to give you that information, because obviously 1361, very common supply cutout fuse standard. But yeah, that's been, it said that spec has been withdrawn and replaced by BS 88-3 in 2010. So you can use that time curve, and just have a look. It's the second row down on page 386. So hopefully that would help that engineer.
That might even be on our Pocket Guide app on the adiabatic calculator on there.
Yeah,
I'm just looking.
Yeah, that's a good point, because it was such a commonly used fuse.
Oh no, sorry, it doesn't have the device. It just, yeah, you'd have to get the time, yeah, to input it on that. Actually, yeah.
Okay, we've got another one. We are doing a large office fit out. AC is being installed. 3-phase 45 amp supply, RCD protection. Would you advise we need to get MOD conversion to make RCD protected, or just on triple pole isolator? Thanks, we've installed all cables. So we're doing a large office fit out. AC is being installed, 3-phase 40 amp supply, RCD protection. Would you advise we need to get not sure what MOD conversion to make RCD protected, or just on triple pole isolator? Thanks, we have installed all core cables. Yeah, might need to just so
yeah,
nothing there that says obviously 3-phase 40 amp supply. If it's hardwired, depending upon how you run the cable, you may not need RCD protection. It's obviously not going to be fed from socket outlets. So yeah, just need a little bit more information in that one. We'll try another. I carry out a lot of installations on metal driving ranges in steel buildings. I always bond structural steel. How far do I have to go in regards to lightning protection? Would that be a client's preference or something I should be looking into? It's really a specialism outside of 7671. So you know, it would depend on a thorough review as to whether lightning protection is required based on the location and where it is in relation to other buildings. So for example, if it's the tallest building in that location, then it may need it even though others around it may already have it. So yes, lightning protection's outside. There is a connection in that we need to bond to the lightning protection system, but yeah, it's not a client's preference whether they have lightning protection or not. It would be done based on a survey of the site and the location.
It's very difficult to provide any guidance on it as well, isn't it? If for a contractor's point of view, for sort of, you wouldn't, unless you're really a specialist in that area. Because BSEN 62305, is it, lightning protection?
And you know, there are specialist organisations out there, people like FIRS, who will do, you know, as well as provide required equipment, will also do that survey to see if a lightning protection system is required for the property. Okay, just looking down through. So the engineer has said that no harm whatsoever, might be over the top, but it's the best way is 5-core armoured, so that you've got an integral CPC. Okay, we'll while we're waiting for some others, let's have a look at. Okay, another good one that's that was a bit of a light bulb moment for me when I was first introduced to this concept. So contractor had a measured prospective fault current in an installation of 15.5 kA, and the protective device in the distribution board only had a breaking capacity of 10 kA, and asked what could they do. And we pointed out to them this principle of backup protection. So so within 7671, and we'll show you the regulations that talk about it a little bit later, but it is possible to use a device with a lower braking capacity, providing that another protective device with the required braking capacity is installed on the supply side, so upstream of the distribution board, and then the let through energy of that upstream device is less than the braking capacity of the downstream device. So that's what's referred to as backup protection. So for example, if you had a fuse at the origin which had the required braking capacity, so it was greater than 15.5 kA, and then the let through energy which you'd have to get from manufacturer's data was less than 10 kA, then your 10 kA device on the remote board would be fine, because what's happening is that large amount of energy will first be seen at the supply by that bigger fuse. The bigger fuse will be able to cope with it and will operate, and all you've just then got to make sure is that for the time it takes to operate, enough energy doesn't get through which is greater than 10 kA to damage your protective device. So that's this backup principle, which is why that we have to align those protective devices throughout the installation, but it can be of benefit to us. So you'll normally find that the larger rated protective devices are located towards the origin of the installation for that purpose. And if we show you the regulation, so it's there, it's 434.5.1, and if you look at the second sentence that we've highlighted, a lower braking capacity is permitted if another protective device or devices having the necessary rated short circuit capacity is installed on the supply side, and in this situation the characteristics of the device shall be coordinated. So what it's saying is, while that big fuse up front can manage with that large energy, it will take a finite time to operate, and so long as the let through energy that it will allow to pass while it's operating, while it's tripping or blowing for a fuse, so long as that's less than the braking capacity of the downstream protective device, then you're safe and compliant with 7671. You'll find that a lot of the design software works on that basis, so that you've got coordination between the different protective devices. We'll take one more and then we'll have a look back in the chat again. So George, what tests need to be completed for an item of current using equipment when electrical separation is being used as the protective measure against electric shock? What's our thoughts there?
Okay, so electrical separation. So what we need to make sure there is that live parts of that circuit, that they're basically isolated or separate from any live parts of any other circuit, and also from earth. So there is actually a regulation for this as well, which I can share. But it would be an insulation resistance test. The minimum values as per table 64 would apply for the voltage band. And it specifically tells you in regulation, so it's 643.4.3. That's 643.4.3. And that basically says just that, confirmation of separation of the live parts. Just open it up. So it's in there, protection by electrical separation, and yeah, separation of live parts from those of other circuits. So the live parts from the other circuits and from earth,
yep.
Basically. To show that protective measure is effective, basically.
Yeah, so it is actually included within Part 6 there, and there are some specific requirements that you need to ensure. But yeah, like you say, it's just confirming that you have actually got a salve situation and that there is no connection to other circuits within that installation. We've got a few other comments that have come in. So I think the engineer that talked about a requirement for lightning protection has asked client preferences. Is there anything I could do that would come back? I think you need to look contractually. So if you're doing the electrical installation, you wouldn't normally contractually be required to provide the lightning protection system. I think it's one of those ones that it's always worth having that conversation and actually providing documentation to make it clear that you haven't provided that, and that it would be a consideration for your customer to investigate the situation and whether that's a requirement. And we've got an engineer that's highlighted on the point. So with consideration towards renewable generation, do we need to start looking towards installation of greater than 100 amp consumer units to allow for these additions in the future within new build properties? And I think, you know, that's a valid point if you think about it, because not only are we perhaps looking at having a DNO supply in addition to self-generation, so perhaps PV or even turbine. Add to that the fact that you might also then have battery storage associated with your PV, which at time could be also feeding in. And when we become more and more reliant on electricity, and so we go away from gas boilers to electric boilers, we've got an even bigger demand. So yeah, I think it's something that's recognised, and we know already about the 7671 requirement to consider those additional loads onto the assembly to make sure that your assembly is adequately rated, and you also need to consider the duration as well. So you need to look at the manufacturer's information about their rated diversity for those circuits that could be pulling large amounts for long periods of time, for example vehicle charging. So yeah, there's a lot of work already, but yeah, I think the standard 100 amp supply to domestic property is getting less and less valid, I think, as electrification improves, and also the amount of self-generation within domestic properties too. So yeah, I think it's key. I can't remember that, but I'm pretty sure that there are manufacturers who are already are putting out a standard 116 amp board. So we've got the general DNO 100 amp plus 16 amp of self-generation capability. So yeah, that's worth it. Okay. Sorry, yeah. George.
Sometimes it just takes time for everything's moving so fast, isn't it? And it just takes a little bit of time, times for everything to sort of work itself out.
Yeah. Engineer has said that they have got another question. I did have another question above if you have time. We will need to have a look because we are slowly running out, or quickly running out of time. Let me just take a look back and see if I've missed one. So I'm not seeing another one. So perhaps if you can pop that in, we'll look for that next time. So a very final one. Where's the maximum disconnection time noted for solar PV systems? So it would be a circuit, so it would have a disconnection time within part 4. It obviously wouldn't have socket outlets, so you would need to look at that, but it will be included within that. And I think we're also aware that the inverter manufacturers, that the product standard for the inverter also gives a shutdown time in terms of if it does lose supply. Okay, once again we've run out of time. Some great questions there tonight. Apologies if we didn't get round to answering your question, but we will store it and try and get round to it next time. So please do post in. Just a few things and a little bit of housekeeping before we disappear. So yeah, if you've not got a copy, George mentioned it in a couple of the questions tonight. If you've not downloaded a free copy of the Pocket Guide app then please do so. For NIC contractors, we've got a very popular wire series continuing, and that continues next week with a coding clinic on the 13th of March at 8 o'clock, focusing on commercial and industrial installations and the observations that people have found in that. And then the last one before the Easter break is a back to basics, which has been asked for by many contractors around automatic disconnection of supply. What is it? What's it all about? And how do you test for compliance with the requirements of it? Please do stay in touch on social media. We're across everything. If you're not signed up for our social media accounts, then please do. And a big push for, we're up at Bolton, so if you're in the Bolton area, if you're considering going to ELEX tomorrow, we had the first day of ELEX today, and it went very well, was very busy. If you're up and around the Bolton area tomorrow, then please do come along and see us on the stand. I'm going to be hot-footing it up there myself in the morning, so hopefully I'll see anybody that's there. And if you can't make Bolton because you're not in that neck of the woods, at the end of the month we're down at ELEX at Alexandra Palace, so please do come along and see us at either of those locations. And lastly, thanks very much for participating tonight. Some great questions, and I can see people helping each other out in the chat, which is fantastic. That's what we're all trying to do. We will be running another one of these on Thursday the 10th of April, so we try and run them once a month, always on a Thursday, but we fit them in around the wire webinars. And these are open, they're open to anybody with a LinkedIn, Facebook or YouTube account, and anybody that's got one of those questions that's been rattling around for ages and always wanted it answered, or perhaps just wanted an answer explained, then please do come along on one of those Thursday night Q&As, and we'll do our best. Any last words or thoughts from yourself, George?
No, just thanks everyone for participating, and yeah, what you said about everyone helping each other in the chat as well, you always see that, and that's what it's about at the end of the day. So yeah, hope everyone has a good evening.
Yeah.
And nearly the weekend.
All right. Yep. No, I would echo those thoughts from George as well. Thanks very much. Like I say, thanks to everybody that participated and put questions and answers in the chat. And if we didn't get round to your question, hopefully we'll get round to it next time. So thank you very much for taking part.